Hi everyone, my name is Namaka and my project is artificial intelligence. So the presentation is going to be as follows. I have the introduction, the view, I would say, the challenges, methodology, the data set description, the data preparation analysis, and the distribution section, the accountability, result. So, seed sorting and artificial intelligence. Seed sorting is the mechanical process in which the goal is to achieve high level purity and quality in the final product. And artificial intelligence is simply simulation of human behavior in computers. So combine the two, we want a computer to be able to process the goal and to achieve high level purity and quality of the final product. Basically, this model aims at solving a solution. So we know after harvesting, we roast so that we can preserve, right? So we roast to different degrees. We have those that don't roast, those who opt to over roast or not roast or mildly roast. So we want our model to be able to separate the seeds for us. Having a human do it is okay, but it will take a longer time. And for it to take a shorter time, we need to deploy more people, which is an expense. So having a model do it for us is simpler and takes less time. Looking at the background, coffee is an export and it contributes approximately 6.76 to our GDP as a country. And this is approximately 49 people who are depending on the growth of coffee. So if we are to automate this task, it's going to not only help the people, but help the country at large, because we're going to have a larger quantity of exports going out there and less expenses. So this is why we ought to automate this task. When a model is learning, there are three types of learning. There's supervised learning, unsupervised, and reinforcement. So supervised learning, the model looks at labeled data sets and it learns from this labeled data set. So when presented with new data or input, it's able to classify this belongs to this and this belongs to that. And using unsupervised learning, the model is trained based on patterns and similarities. So it will look for something similar, things with a similar, let's say, a similar feature and put them in the same category. For reinforcement, it's a type of learning that takes place with a reward and penalizing. So given a model, we're dealing with image classification, we're going to do more of supervised learning, where we're going to concentrate on convolutional neural networks, naive Bayes and support vector machine. So the convolutional networks are, in summary, is a framework of brain. We have interconnected nodes where at each layer, the output from each layer is used as input. So these nodes form that structure that's going to help form that complex function that's going to map an input to an output. Then the support vector machine, we have a boundary that separates. So when a new input comes, it will be separated. This belongs to this side of the boundary, this belongs to that side. And naive Bayes is probability. It assumes independence and it assumes that features are independent and works on the theorem of the Bayesian theorem. So in unsupervised learning, it wasn't really deployed here so much, but some of it clustering. So clustering is basically getting the similarities, input with similar data with similar features, put it on one side or into a category. Then the challenges we face there is hyperparameter training. It's not easy, and someone getting it at the first try is very hard. So you keep on try and error, enter an activation. Is it the one that works? trying to reduce the learning rate. If I increase the learning rate, will it learn or will it memorize? So there is that challenge. You have to keep going back and forth. And then there is overfitting. In neural networks, more tends to memorize and learn. So there are high chances of this model memorizing the data instead of learning. So when it's presented with new information, you can hardly identify or make the correct predictions. And then we also need a large quantity of properly prepared assumption properly. And so if you present it with garbage, you get garbage. So garbage in, garbage out. Then the assumption of independence, this works for the naive phase. Like we assume independence, but that's not true. Features actually relate to each other. So the assumption of independence is not right. And then you have a problem with the challenge of the black box, especially with the network. Like when I put in my input, I do not know how it works out, but I'll have an output. It's going to go through the layers, but the science behind those layers and everything actually don't know. So we won't have an explanation as to why it has classified it as black or brown. Then the solutions, the data set I acquired actually was already divided into test and train, but I combined them to form one large data set and I divided them into a ratio that I saw it 7 for the ratio of 7:1 to 2, where 7 is training, validation, and testing respectively. So this helped make sure the model does not overfit. Then the use of the try and error for the hyperparameter training, as I explained. Go back. Is this giving me the output I need? If not, go back, change like the learning rate, change the activation, find something to change, make sure your model is actually working the way it's supposed to work. And then according to research, it shows that there should be a minimum of like 4 layers. But when I dug deeper, even 1 layer can work, provided you make the correct evaluations. So with the correct valuations, I used 1 layer and introduced the computation time. Then a methodology. These are basically the steps that have been followed when coming up with this model. There is data collection. So data collection is, a model can't work without data. So you go collect the data. The data is taken in the form of images of things that have been rested. And then you have to explore. Exploring is basically visualizing, describing the data. So get the data, describe it, find then how values. Is it a histogram? Like how is it relating with each other? So that's what happens in data exploration. And then if I look at preparation, you're making sure that the data is suitable for the machine learning technique. Check for the null values, check for duplicates, all those things. That's when you have to make sure it's suitable for the machine learning algorithm chosen. Like, then we'll have the modeling. Actually, the other first 3 stages take up most of the time. Then modeling is just applying that technical data. So here we shows the neural networks. So come apply neural networks here and see the outcome. Then you have to evaluate. Is a model actually learned? Is it able to predict? Is it able to make that classification? That's what happens in the evaluation stage. The data set description. This data set that I worked with has 4,800 images. And these images, as I said, were collected by different, by taking pictures of different seeds. Then what I put into consideration when making, when picking this data set, the accuracy, it was accurate. It had the images that I needed, and then the relevance. It was, these images are what I needed for my work. I needed images for seeds, and that's what it had. And the quality was very good. The images were clear. So I opted for that, and also the variability. Then when I look at the preparation exploration, you're preparing it, you're describing the data at hand. Check for the duplicates, check for the null values. That's what I did here. Clean the data. Unfortunately, we realized there were no there were no null values. But in an instance where you have null values, take the average of the none of the other values in the data set. That will work for your null values. And then the model selection and optimization. Now we'll take a look at the convolution neural network. And with this, we have interconnected nodes. And parameters, these are values that are predetermined before you run. So the parameters have like the number of convolution layers, the filters, the size of the filters. So these are determined before you actually run. And then the hyperparameters, these are things you change along when the model isn't working the way it's supposed to work. So that's the learning rate, the batch size, the number, the optimizers. Those are things you change according to the outcome you have. Then you have the support vector machine. As you said, it's binary classification. This falls in this side of the boundary. This one falls in this side of the boundary. So classify them like that. So you have to choose, if you have the parameters, you have to choose a function. Is it linear? Is it linear? Is it radial? The cost values are predetermined figures. But this again can work as a hyperparameters because you can keep changing them. Then we'll have the random forest. Random forest is basically combining different decision trees to make a prediction. So when I get my decision trees, I make them as one and I form my forest. So my predetermined value should be like the maximum depth of entry, the number of trees that I'm putting in, and then the hyperparameters. Things that should change, you keep adjusting the number of trees, you trade off the accuracy or the computation time. So those are things you put into consideration, the number of the trees that you put in how they split. So these are things you put into consideration. Then the accountability, who's held accountable for this model? That's a governance, the performance. Is it performing to its expectation? And what kind of data is it dealing with? Who monitors the model? So this is where explainable AI comes in. This model will be able to make a prediction or a decision and it will back its decision. I've chosen this because of this. It helps us solve the black box problem. That's how explainable AI comes in. And then we'll have the results and evaluation. We use the accuracy, precision, F1 score, and recall to make our evaluation. And me personally, I concentrated on accuracy, which is a ratio of the correct predictions to the total number of predictions. How right is your model? In all those predictions you made, how many of them were right? And then we'll have precision, which is a ratio of true positives to the sum of the true positive and false positive. How many positives were correct out of the total number of positives that you got? And then the recall, the ratio of true positives to the sum of true positives and false negatives. Then I'll have the F1 score, which is a ratio of the product of precision and recall to the sum of precision and recall, and we have to multiply that by 2. So these are various evaluation metrics. In conclusion, this model is going to help us package. We all have different consumer demands. You may want to see that are overly roasted. You may not want them. So it's going to help us cater for those different consumer demands and give the consumers choice. And it's also not only going to help an individual, but it's going to help the country at large because it's increasing its bargaining power in the world market. So in short, it's going to be a great advantage, not only the society, but also to help uplift the economy. Thank you and have a good day.